Hello everyone. Now we are going to start earthquake design. But before starting the earthquake design, let me tell you that what are the things we have completed in this model. So if you look at now the steps that need to be performed in ETAPS model is written here, and in these steps we have completed the first few steps, that is the modeling part. So we have completed the modeling part. This we have completed. We have completed the checking the warning message. We have completed the applying the fixed support. We have completed the applying the gravity loading. We have completed applying the moment release. Model analysis also we have completed. We have also completed the control or deflection checks, where we have looked at the deflection, and also we have studied there the creep analysis also. The 10th step, which is that applying the earthquake, is there, and we need to see that how we can apply the earthquake design our building with the earthquake analysis. So what are the steps you have completed now? You can just write here that these are the steps. So you can write Y for yes, we have completed this. So we have completed these many steps, and this step need to be completed applying the earthquake force, and that also static one. I will share this sheet in the download option. Now come back to the ETAPS model. So this was the model which we were doing, and in this model only we will apply the earthquake forces. Let me tell you very important things here. Applying earthquake forces requires a very less step only. In 5 to 6 step only your earthquake forces will be applied in ETAPS. But we have to understand in very detail that how the forces will come and all the theory behind, and also the core concept of earthquake analysis in our lectures. Let me open the PPT to explain you the theory part of the earthquake analysis. So this PPT will be available for you also in the download section, so you can download it and study. So you can see here the topic which we have to study. The first thing is the different method of performing earthquake analysis by the code approach. The first thing that you have to know that the earthquake design which you perform in your building is given in IS 1893. So IS 1893 is the code where you will follow all the guidelines which we have to perform in earthquake design. So the latest is the IS 1893 2016, and this code I will open and I will show you. This is the latest code of IS 193 part 1. So this has been released in 2016. Now I will show you some glimpse of this code, and also I will tell you the important things here that you can study from this code, so that it will be very easy for understanding the earthquake design, and also very easy to make the building earthquake resistant. So if you come here, there are a lot of terminology here. You can study few terminology here, and if you find any problem in terminology definition, you can ask me in comment box. Also if you come here, you will find in the page number 11, which will be a map of India, and here in this map you will find the different zone here. So if you look at now, our India has been divided into total a 4 zone 2, zone 3, zone 4 and zone 5. So we are going to study very detailed here in this particularly map also later on. So according to this Indian standard, the upper part, if you look at now, like the part of Delhi, and if you look at some part of your Ladakh, Jammu and Kashmir and all, will come under the zone 4. Also if you look at the Gujarat, Bhuj will come in the zone 5, and also if you look at the some part of Guwahati, if you look at no Imphal and all, it will come under the zone 5. If you're doing any building in the Bangalore and all, in that cases it will come into zone 2. And if you're doing any building in somewhere in the Gaya, or you're doing in the Lucknow and all, it will come in the zone 3. So the India has been divided into a total 4 zones, and we actually apply earthquake forces on the basis of the zone only. If you come more below, you will find a graph here. This graph is the SA by G versus a time period graph. So we calculate the natural time period of your building, and we see that what is the SA by G is coming for that time period, and we apply the forces. So we have two graph here. One is used for the doing any static analysis, and the second is used when you are doing the response spectrum analysis, that is the dynamic analysis when you are performing. When you come more below, you will find out a different irregularities that actually come in your building, and we have to perform this type of irregularities in your ETABS model also. So later on the lectures I will teach you that how to perform different irregularities in your building, and also I will teach you that how you have to perform the mass irregularities, plan irregularities, story stiffness and all. There are a lot of things that we have to perform in your ETABS model here. Also, if you look at now, we have a different importance factor on the basis of for the build structures also. Like if you're doing any hospital and all, in that case your importance factor will get changed. Also, we have response reduction factor and all. So we have a lot of things we have there in the this code, and we will try to study these all things in very detail, and also we will perform the earthquake analysis also in very detail in ETABS. So if you come below, there is a clauses which will guide you to perform the dynamic analysis also, and also there will be clauses which will be used for doing the vertical analysis also. So if you look at now, currently as per our Indian practice, you will find out that a structural consultancy are doing only the horizontal analysis also only for earthquake. But if you have very large cantilever and all, and if you have a tall building structure and all, in that cases you have to perform the vertical analysis also of earthquake. So there is two component, one is the horizontal component and second is the vertical component. So we will do that type of analysis also in the ETABS model, and there are a lot of things that we will study in ETABS model, and also we will study in the code also. Now come back to the PPT which we were studying. So we were studying that different method of performing earthquake analysis by the code approach. So if you look at the IS 1893, there is a two method of performing earthquake analysis. One is from static analysis and second is from the dynamic analysis. Suppose in our building, if I want to perform a static analysis, then we have to follow the equivalent static analysis method to doing a earthquake analysis. And if you're doing a dynamic method, in that case there is three method that has been defined in IS 1893. One is your response spectrum method, and second is your time history method, and third is your model time history method. So one by one we will look at this procedure of defining the dynamic analysis by all the three method, and also we will look at the static analysis method also. So first of all, let us start with the equivalent static analysis method. Now let us look at the calculation of the base shear by the equivalent static method. If you are following the equivalent static method, in that case how we need to calculate the base shear is given below. So if you open the clause number 7.6.1 of IS 1893, you will get a calculation here that how you can perform or how you can calculate the base shear for the building. So if you look at the formula here, the VV, which is given AH multiplied by W. So if you look at the AH we call it design horizontal acceleration coefficient values, and this values is given in 6.4.2. So if you look at this clause 6.4.2 just given here, it is written here that AH is equal to Z by 2, that has to be multiplied by SA by G by R divided by I. So if you just want to rearrange this formula, it will be looking something like Z multiplied by AC by G, and that has to be multiplied by importance factor, and there will be 2R. So just I have rearranged this formula and I have written Z multiplied by SA by G multiplied by importance factor, and that has to be divided by 2R. So we will look at that what all the these Z, SA by G, I and R are there. But before going to that, one more important things that has to be multiplied with AH is your W, and W is the seismic weight of the building, and we have to calculate the seismic weight of the building also. So the weight of the building which you are like calculated is different as compared to seismic weight of the building. So seismic weight of the building will be quite different from the weight of the building. So in this AH formula, if you look at that, we call it design horizontal coefficient. In this formula you will get it a different term, that is Z, SA by G, R and I. So let us see that what all the terms are there. So Z is the seismic coefficient factor. This seismic coefficient factor is given in the table number 3. So if you open your IS 193 code, and when you will open the table number 3, so let me open that table. So if you look at this table number 3, here you will find that seismic zone factor. So for every zone there will be a zone factor. Suppose right now if you're doing a building in the Bangalore, which will coming under the zone 2, will have a factor of 0.1, zone 3 0.16, zone 4 0.24, and zone 5 0.36. We have a different factor for different zone. So the first thing that you have to do in the zone factor is to find out that what building you're doing will come under which zone. So I will show you once again that particular table where from where you can just find out. So when you will come below, you will find one table where it will be written about the zone also. So if you look at in if you're doing a building in somewhere in the Bokaro, then this will come under the zone 3, and also along with that there will be a zone factor also written. So you have to always look at this particular annex E, and you have to find out that which building is coming or which city is coming under what zone. Now let us come back to our PPT. We have seen that how you can have a zone factor, or the second important thing is that importance factor. So the importance factor, I will tell you that if you come in our PPT at the last page, you will find a topic called importance factor. This screenshot has been taken from the same code, that is IS 1893 only. And if you look at this clause here, it is written clearly in the table number 8, importance factor. So for various buildings they have given you the importance factor. Suppose that if your building coming under the any hospital or any monuments, lifeline building, emergency building, any exchange, telephone exchange building, television station building, or any metro type building, okay, so like that structure if you're designing, in that case you have to take a importance factor 1.5. If your building coming like a normal a residential building, just written here, just you can watch here, all other building, means if your building is not coming under the condition number 1 or 2, in that case you have to use all other building, and in that case there will be as a one importance factor. If you look at the second number, it is clearly written that a residential or commercial building other than 1.2 listed in serial number 1, which is serial number 1 is the one with occupancy more than 200 person, means that if you're designing any building and that building is not coming under the serial number 1, which is given here, like the metro building and all this type of building is not coming under the serial number 1, in that case if the building occupancy is more than 200 people, in that case you have to use 1.2 as a importance factor, or rest of the building will be used as a 1 only as a importance factor. No need to give any extra factor there, you can use it 1. Also, if you look at the notes here, it is clearly written that owners and design engineers of the building or structure may choose the values of importance factor more than those mentioned above. You can have a rights to choose a more factor of safety, or we can say importance factor, if you want to make it in your design. You one thing that you have to remember, that you no need to reduce it any factor, you have to increase only. You have given a permission for increasing, not a for the reducing purpose. So come back to the again that H calculation, where we have seen that what is the Z, and now we have already looked at what is the importance factor. So next terminology is a R. You can see the response reduction factor. Now let us look at the R factor, or we can say response reduction factor. So if you come the last page of the PPT, here you will find a screenshot, which again it has been taken from IS 1893 only, and on the basis of your lateral load resisting system, there is a R factor given. So if I will zoom and show you this part, you can just find out that for the different structural system, we have a different R factor also. If you are using any structure which is a RCC building with ordinary moment resisting frame, that we will call it OMRF, which means to say ordinary moment resisting frame. In that case, we are using R as a 3. Same if you are using a seismic moment resisting frame, or we can say a special moment resisting frame. In that case, we are using R as a 5. So like that, on the basis of lateral load resisting system, we have different R factor. If you just watch more few lateral resisting system like a dual system and all, in that case you can just see here, if you're having a dual system where there will be a shear wall also and there will be a column also, in that case if you just watch here, like a building with a or if you just see here the building with ordinary RCC wall and RC OMRF, that is a ordinary moment resisting frame and ordinary RCC structural walls, in that case the R factor is 3 only. Like that, if you are using a building with ordinary RC structural wall and with RC seismic, or we can say a special moment resisting frame, in that case you have to use R as a 4. So for different structural system, we have a different R factor also. Now you have looked at how the response reduction factor is going to be vary on the basis of lateral load resisting system. But you have not studied that the definition of response reduction factor very clearly. Now I will explain you this definition of response reduction factor in very simple example. Now try to understand this example. If you will understand this example now, then for you it is very easy to understand the response reduction factor, that is a R factor in the calculations. So if you look at the calculation here, I will just write out the calculation, that is AH equal to Z multiplied by I multiplied by SA by G. This was the calculation, and that has to be divided by 2R. So the R is the response reduction factor, and also sometimes we call it a force reduction also. So you may call a response reduction factor, or also you can call a response reduction, or we can say force reduction. In this particularly, in this H value, we have already seen the Z, I, and we are still left with SA by G, and we have seen that some part of the R there. Now we are going to understand that R very clearly. So let me draw one building to explain this R factor. So assume that this is my building. Now think that earthquake is a displacement, not a force. So I will write here EQ is a displacement, not a force. So for some time you assume it like that. Anyhow, in the realistic, earthquake is a displacement only. If earthquake will come, no, it will cause a displacement, it will not cause a force. But if you look at the codal approach, or we can say any IS 193 approach, it is clearly said that we have to first calculate the base shear. The base shear is what is, this is one type of force only. Okay, so the codal approach is quite different when it comes to the real approach. So if you look at the real, or we can say realistic, the earthquake is a displacement, it is not a force. Okay, so I will just write here that suppose that if I want to design this building with delta displacement, I'm just telling that I need to design this building on the basis of displacement, not on the basis of force. So if I want to draw the graph here, which will be a force versus displacement graph. So for the designing for up to this displacement, that is a delta, or you can just write delta 1, that is a very good indication. You can write it delta 1, which will be indicating, because we are getting into 3 delta here. so that the design delta which will be kept as a delta 1 only. So let's suppose that this delta 1 is coming here and I need to design this building with delta 1 displacement. So if you look at the force that has to be given to this building for designing this delta 1 is the VB1. So VB1 actually it is a force which is has to be given to this particular building to design with delta 1 displacement. So the system 1, I'm just writing here system 1. So this is the system 1, and in this system 1 I have designed my building with a delta 1 displacement with VB1 forces. And just let's suppose that this is a any system which I name it as a system 1. Let's suppose that another system comes. I mean to say system in the system means here a different a load resisting system. Maybe it could be a RCC building with a special moment resisting frame, or it may be RCC building with ordinary moment resisting frame. Just I am taking an example to show you that I am not taking the real system name, I'm just naming it as a system 1 or system 2. So in this case, if I have taken a system 1 here, and in that system 1 I have taken a design, or we can say I have designed with a delta 1 with the base shear of V1. Let's suppose that take another system and you need to design with the same delta 1, but in that case what you have to do, you have just came here and you have increased a ductility in the system 2. So when you have increased the ductility in the system 2, in that case what is going to happen, your the base shear got reduced. Now you are getting a base shear of VB2, means force got reduced. So if you change the system here to system 1 to system 2, and in this particularly system 2 you have increased the ductility in your building, in that case your the force got reduced. If you look at now, the force reduction has been done here, and that's the role of the R factor comes. If you use the different system with the system which will have more ductility, in that case the force will get reduced. That's the meaning of response reduction factor. That's always you can see, if you're using a more ductile in your building, in that cases you are getting a more R factor, that is a 4, and in that case your forces will get reduced. If you want to design for that much of displacement, you have to design with lesser force there. But important thing is come here, that when you're using more ductility, or we can say if you're giving a more ductility in your building, in that case you have to detail that building, or if you have to make a detailing in your building by following the codal provision of IS 13990. So this codal provision is made for detailing purpose with a special, or we can say a seismic moment resisting frame, or if you having, or if you want to give a more ductility in your building, you have to follow this particular code here for detailing purpose. Now you have clearly understand the importance of the R factor in your design calculation, and also you have clearly understand that if you are using a larger R value, in that cases the forces will get reduced, and that's the reason why actually if you're doing any building in the high seismic zone like a zone 5 and all, in that case you are going to use a special moment resisting frame like a R factor 5. So in that type of the building, or we can say in that zone of the building, will require a more base shear, and if you use a ordinary moment resisting frame, in that cases your forces will be more and you have to design for the more forces there. But if you're going to use as a R factor 5 with a special moment resisting frame system, in that cases the forces will get reduced and you will be designed with a lesser force only. But remember that in that cases you have to give the special moment resisting frame, and you have to detail that a structure with the IS 13920 code. That's very important thing that we have to understand every time when we select our response reduction factor. If you select a response reduction factor as a 3 only, which is a ordinary moment resisting frame, in that cases you no need to detail your building with IS 13920, because this IS 13920 is meant for the ductile detailing only, not for the ordinary detailing. Okay, so I think it's very clear to you. the R factor, or we can say response reduction factor.